we're going to look at strengths of solutions. We can write the strength of a solution as a ratio, a fraction, or as a percent. So in this example, we're going to make them into fractions with labels of pure drug and total volume, and we're going to show all the strengths possible for each strength of the fraction. So if we look at this, the fraction 5/20, if it was a solid, would be 5 grams over 20 milliliters. If it was a liquid drug, it would be 5 milliliters over 20 milliliters. Now we can also simplify this, and more often than not, we'll want our fractions in simplest form. If we have that 5/20, they can both be divided by 5, and that gives us the fraction 1/4. So if it was a solid drug, we'd say there's 1 gram in 4 milliliters. If it was a liquid drug, we'd say there's 1 milliliter in 4 milliliters. To write this as a simplified ratio, whatever our numerator is, in this case the 1, comes first. Whatever the denominator is, in this case the fraction, comes second. To write it as a percent, we do our numerator divided by our denominator. That gives us our answer in decimal form, which would give us 0.25. Remember, to get to a percent, you either bump the decimal point to the right 2 places, or you multiply that decimal number by 100%, and that gives us that answer of 25%. If we look at another example, we're asked to write the strength as a percent ratio and fraction. If we look at this, we see that there's 5 parts solution and 1 part solute. That solute would be the drug. And they tell us that the water, the solvent, makes up the other 4 parts. So if we were trying to write this, I'll write it as a fraction first, we would write it as 1/5. Now they don't tell us about the drug, whether it's a solid or a liquid, so we could write it as 1 milliliter over 5 milliliters, or we could write it as 1 gram over 5 milliliters. These fractions are all simplified, so to write it as a ratio, I would write 1/5, my numerator to my denominator. To write this as a percent, I do the numerator divided by the denominator, which gives me 0.2. That's my answer in decimal form. To write it as a percent, I bump my decimal point over 2 spaces and fill in that blank space with a 0, or we multiply by 100%. Either way, we end up with 20%. The next examples have the directions write the strength of the following examples as a percent, ratio, and fraction. The first one says, give the strength or concentration of a medication containing 15 milliliters of pure drug mixed with 35 milliliters of water. Now for this one, we have to do some upfront work. Notice the 15 milliliters are pure drug and the 35 milliliters are water, so they're the diluent. To figure out the total solution, we have to do the 15 milliliters plus the 35 milliliters. That tells us that the solution is 50 milliliters total. Once we have that, we can write our fractions, ratio, and percents. I always do the amount of the drug, so 15 milliliters, over the total solution, which would be 50 milliliters. But we can simplify this. Both frat numbers can be divided by 5. If we do that, we end up with 3/10. So 3 milliliters to 10 milliliters as our fraction. To write this as a ratio, I would write 3/10. To write this as a percent, I do 3 divided by 10, which gives me 0.3. That's my answer in decimal form. To get this as a percent, I bump my decimal point over twice, or I multiply by 100%. Either way, I get 30%. If we look at this next example, it says there are 70 grams of a drug dissolved in 140 milliliters of a solution. What is the strength of this solution expressed as a fraction, a ratio, and a percent? So the drug will always go in the numerator, and in this case we know it's a solid because it's the 70 grams over our total solution, which is 140 milliliters. Once again, I can simplify this fraction. Both numbers can be divided by 70. When I simplify this fraction, I end up with 1/2, and the units stay the same, so 1 gram to 2 milliliters. In ratio form, this is 1 to 2. To write this in percent form, I do 1 divided by 2, which gives me 0.5. To get it in percent form, I multiply by 100 or bump my decimal point over 2 places to find that it is a 50% strength solution. If we look at another example, it tells us to read the label in figure 8.8 and verify that the two strengths stated on the label are equivalent. They give us two strengths. One of them is this 2 milligrams per milliliter. The other is 2%. I'm going to focus on the 2 milligrams per milliliter. Remember, when no number is written, it means that there is a 1 there. Now this is not in the proper form because milligrams is in our numerator and it should always be grams. So the first thing I'm going to do is convert from milligrams to grams. I know there are 1,000 milligrams in 1 gram. When I multiply straight across, that gives me 2 over 1,000. Or when I simplify, 0.002 if I do the division. My units in the numerator are grams because the milligrams cancel out, and in the denominator is milliliters. I know to go from that fraction to a percent, I divide, which I already did, but just to show it, I'll divide by 1. That gives me that 0.002. Remember, this is our answer in decimal form. To get this into percent form, I bump my decimal point over twice or multiply by 100%. Either way, I get 0.2% or 0.2%. And if we look, that is the same as the percent on the label. So we can say yes, the strengths are equivalent. When we're looking at some questions, here are some steps to help us follow a process that will work. You'll be given a strength of your solution expressed as a ratio, a percent, or a fraction. You should put this strength in fraction form, labeled pure drug and total solution, and write down both options for the strength. You should underline the question being asked to see if you are looking for the pure drug or the total solution. The keyword is solution. You should label your answer with what the question is asking and start your setup with the same label you want your answer on the top of the strength fraction. Then set up your next fraction with units to cancel in the numerator of the second part of your setup. The second fraction should have a 1 in the denominator. Cancel units to find the answer. So if we look at some examples, it starts with how many grams of a drug would be needed to prepare 1 liter of a 1:5 solution. So they gave us this 1:5 ratio. I know that means 1 part drug over 5 parts solution. If we look at this, they're telling us how many grams of the drug. So that tells us our drug is a solid in grams and the solution is a liquid. The 2 ways means that we can also write this as 5 milliliters over 1 gram. Our dimensional analysis will show us which way we actually need. So we're told that we need to prepare 1 liter of solution. Remember, the 1 is the drug, the 5 goes along with the solution. So if I start out with 1 liter of solution, I can put it over 1. I'm going to use the strength to cancel this out. I want the solution to be in the denominator, but my units are different. I have 1 liter from the problem and milliliter for the solution. So I'm going to convert my 1 liter into milliliters. Then I can use the strength. I want the 5 milliliters to cancel out, so my 1 gram will be up in my numerator. When I multiply straight across, I end up with 1,000 over 5, which gives me 200 grams. So I'll need 200 grams of this drug to prepare 1 liter of that 1 to 5 solution. In the next example, it says how many grams of dextrose are contained in 30 milliliters of this solution. They tell us that the solution is a 50% solution, and they also give us the strength as 25 grams over 50 milliliters. Remember, we could also write that as 50 milliliters over 25 grams, depending on what the problem asks us for. So they're asking us how many grams of dextrose are contained in 30 milliliters of this solution. So they're giving us 30 milliliters solution. I know I want to use my strength, and it does have the correct units, milliliters, so I want the 50 milliliters to cancel out, and I'll have the 25 grams of the drug up in the numerator. When I multiply straight across, I end up with 750 over 50, which gives me 15 grams. If we look at the next examples, it says how many milliliters of a 20% magnesium sulfate solution will contain 40 grams of magnesium sulfate. That 20% is telling us that we can write it as 20 over 100. We know percent always means per 100. Because they're telling us that it's 40 grams, we know the pure drug is grams, and the solution is always milliliters. Remember, we could also write this as 100 milliliters over 20 grams. Now, we have 40 grams of the pure drug. We want to know how many milliliters of the solution we could use. So in my dimensional analysis, I want the 20 grams to be in the denominator to cancel out, and the 100 milliliters to be up in the numerator. That gives me 4,000 over 20, or 200 milliliters of this solution. The next example says how many milliliters of the mannitol solution shown will contain 2 grams of mannitol. If we look at this label, they tell us that it is a 5% solution. So that 5% solution tells us that we have 5 over 100. They tell us that the drug is a solid within the question, so we have 5 grams over 100 milliliters. Remember, we could also write this as 100 milliliters over 5 grams. So they say that we are looking for the milliliters that contain 2 grams of the drug. So I'm going to start with my 2 grams over 1. I know with my strength, I want the grams to cancel out, so I'll want the 5 grams in the denominator and the 100 milliliters in the numerator. When I multiply straight across, that gives me 200 over 5, or 40 milliliters. We can double check that the grams cancel out. The next example says how much hydrogen peroxide would you need to prepare 300 milliliters of a 2/3 strength hydrogen peroxide solution for a wound irrigation. We're expected to know in this example that hydrogen peroxide is a liquid. So with that 2/3 strength, that tells us that we have 2 milliliters of the pure drug to every 3 milliliters of that total solution. Remember, we could also write this as 3 milliliters solution to 2 milliliters drug. If we look at this example, they're asking us how much hydrogen peroxide. So we're looking for how much drug. We would need to prepare 300 milliliters of this solution. So we're given 300 milliliters solution. I know I want my dimensional analysis to cancel out the milliliters of solution, so I want to pick the strength that has 3 milliliters solution in the denominator and 2 milliliters drug in the numerator. When I do that, the milliliter solution cancel out. When I multiply straight across, I have 600 over 3, or 200 milliliters of the drug, so of the hydrogen peroxide. The next example says how many milliliters of a 1/4 strength Sustacal solution can be made from a 12 fluid ounce can of full strength can of Sustacal. So if we look at this, the strength is 1/4. And notice, yes, I apologize. Notice that it's a 12 fluid ounce. They are both liquid. So that means we have 1 milliliter of drug to 4 milliliters of solution. And remember, we could also write it as 4 milliliters solution to 1 milliliter drug. Now we have a 12 fluid ounce can of full strength Sustacal. The issue is our strengths are always in milliliters. So I'm going to take these 12 fluid ounces and convert it to milliliters. I know that there's 1 fluid ounce in 30 milliliters. So we really have 360 milliliters of pure drug. Then I can set up my dimensional analysis. So I have 360 milliliters of drug. I want that drug to cancel out, so I'm going to pick my second strength, the 1 milliliter drug in denominator, the 4 milliliters of solution up in the numerator. When we multiply, the milliliters drug cancel out, and we end up with 1,440 over 1, which is just our 1,440 milliliters of solution.